Okay, so welcome to Guided Study Group week. Um, it's not actually any week. It's maybe week 6, no, week 5. But yeah. So today, as I mentioned last Thursday, we're gonna have like an exam review of all of the materials we cover in lesson 2, lesson 5, and it's also kind of like an official exam review anyway. And then I picked some of the questions that I actually did your practice exam myself, and I just picked the questions that I got wrong because not many people actually did it yet. So I just cannot really like take their data and like put it into here and kind of work on it and try to explain it to people. But I did it myself and I picked the wrong questions that I got and put it here. So first, let's get started with the materials from lesson 2. So in lesson 2, we learned something like margin of error. So it's kind of like allow us to um, determine if the sample is reliable enough based on their sample size. And so margin of error allow us to margin of error is proportional to 1 over square root of n, with n be the sample size. Wait, hang on. I actually need, oh, it's recorded. Okay. And it's independent of the population size. So this is the tricky part. Say if you have a very big population or very small populations, regardless of your sample, margin of errors, regardless of your populations, margin of error is going to give the same value if you have the same sample size. So even if you have a very big populations but a very small sample size, or a small population and a small sample size, it doesn't really make a difference in the reliability based on margin of error evaluation. Then we have sampling types. So just different techniques that we're gonna survey our sample or like pick out samples. So first one is simple random sampling. So basically we have a sample frame where we have like most of the data or most of the subjects in the populations, and we just pick randomly based on like, choose a random number and then pick that person. Or we have two special techniques called stratified sampling and cluster sampling. So stratified sampling is that when you have a big population with a lot of characteristic, but you divided it into smaller groups with certain characteristic for each of them, and just pick like a small portion of each of them. And now all of that little thing little sample combined together to be your overall sample. So that is when you have divided it into groups and called strata and pick a portion of each. Another one is called cluster sampling, when you have divided a population into groups of, so say a population that have certain characteristic, but you only make it into smaller groups, and you just survey everyone in those certain groups that you pick. So say you divided it into 5, but like there's not that much difference among all of them. So you just pick like 1 or 2 groups and you survey everyone in that groups. So that's cluster sampling. So that's a big difference is that when you have stratify and cluster sampling, stratify is going to survey just a small portion of each stratum, and cluster sampling, you survey everyone in a group, but you only pick certain groups. While stratified sampling just survey a portion of every group. So that's like the main difference. Then we have systematic sampling, kind of like simple. Say you pick someone based on a rule, like pick one every 10 people on that list. And then finally, we have non-probability sampling schemes. So these are the ones that we don't usually use because they tend to have some bias and low reliability. And those that usually come from maybe you have volunteer, convenience samples, self-selected, or haphazard samples. So yeah, so these are the ones that kind of we call disaster sampling, where we try to avoid them because you have to deal with a lot of bias and kind of like result analysis later, see if it's reliable or not. Then we have different type of study types that we learn. Most the two most important one are observational studies and experimental study. And so the only difference between the main difference between these two is the need of randomization and the use of treatment. So in observational study, as we discussed before, there's very little control on the subjects. Like the researchers cannot just randomly assign the subjects into groups and kind of like learn their characteristic, because those characteristics is already in their life. So they have less control in observational study compared to experimental study. So you cannot really do the randomization, assign them into groups. And also in observational study, as the name implies, we can only observe like how those changes in their life. And so we cannot apply any treatment, say like you cannot assign, okay, this one do that jobs and the other one do the other jobs. So that's, yeah. And so that's why the result from observational study only allows you to draw maybe like an association, like these, if this one increase, the other one might have this train, but it doesn't allow you to imply like something caused something from an observational study. But that's something you can do for experimental. Then we have some case control study. So these are like the more, kind of like observational study, but different way to improve it. So we have techniques called retrospective and prospective. So retrospective is where you select like your samples with certain traits, and then you select from the big population some other subjects with many similar traits except for one. And that's the trait that you want to study the effects of. Prospective study is where you select a sample and you kind of like want to study some trait, but you do the observation through over time. So it takes a lot more time and efforts, and also there are a lot of confounding variables, which we're going to talk more in the next slides. Then we have matched pairs. So this one, a very representative thing that I usually think about is where you have like an experimental study where you have people try out the some groups try out the weight loss package, and the other one doesn't try any weight loss package at all, and they weigh themselves at the beginning and at the end of that package and see if there's any changes. So each person is going to have two values, before and after the program. So that's how I remember match pair, but that's an experimental one. So an observational one is where you cannot assign them into groups and they just already started a package or something on their own, so you can only observe their changes. Then we have some other concept that we don't actually discuss much, but I think you should know in any kind of research study, is we have subject blinded. Subject blinded is that when you have a subject doesn't really know like if they receive the treatment or not, and like if they're what groups are they in, they don't know about their own characteristic compared to other in the study. Research blind is that when they apply maybe treatment or interact with different subjects in the study, but they don't know which group they are in. So then the researcher is the one who don't know the groups. Or double blinded is where you have none of the other know whatever their characteristic is. They only know one is researcher and one is subjects. So the double blind, these blinded thing is kind of like ways that develop in the research study field to try to improve the reliability and reduce the bias from the researcher and also from the subjects. But we don't really discuss much, so you guys can always like Google it if you need more information on it. I feel like, because in my field it's pretty like, self-explanatory, so I don't know how to actually explain it for that, so that you guys can understand what I'm trying to say. So we have this table. I think it's in week 2 when we do the lesson 3 or lesson 4. So where we have different types of samples going to different type of studies, and we have for experimental we have randomization, and there are different use of randomization. So if you have two experimental with 2 independent samples, then we can randomize type of treatment. The other one, if you have experimental with 2 dependent matched pairs, then you can have randomized order of treatment. So yeah, and then in observational study, of course, we don't have any randomization at all. Then we talk about variable types and measurement issues. So variable types is mostly just like how we like terminologies about the concept we're trying to learn in the experiment or in the research. We have explanatory variable. It's kind of like, say, if you want to study the effects of something on something. So the factor that changes it and make the effects is the explanatory variable, and the results that you try to measure, say like the weight, the height, blood pressure, it's the response variable. So yeah, explanatory variable is used to explain the difference in the groups in randomized experiment. Yeah, must be randomly assigned as well, just to like improve the bias and reliability, and also like it's kind of like the core principle of experimental study. There's something we also call confounding variable. Basically, it's just a thing that we don't actually account for during our design of the study, but it can have the impact on your result. And it may be not the factor that you try to study in this research. We also have different types of variables based on their values and their categories, with called categorical variable and quantitative variable. So kind of like categorical, kind of self-explanatory, where they say you can only answer it as a category, yes or no. But quantitative is where you answer it with a number. Now, well, categorical, the nominal variable is the one that doesn't really have a meaning to the value. So say if you have like first or second, but they say, okay, that's a nominal variable, then you can assume that first or second doesn't actually mean an order. But they say if they say it's ordinal variable, then it actually means an order of first or second or third. For quantitative, we have discrete and continuous. So discrete is very clear. Say if you say in the year you have 1977, 1978, but you don't have 1977.5, so that's when you call something like discrete. But for continuous, so like say your weight or your height, they can be 0.5, 0.4. You can take any values in a range, a continuous range. So that's like the main difference. And these categorical and quantitative can, depending on what variable are involved in your study, can determine the type of data display. So one of the very easy thing is, say we talk about scatter plot. So scatter plot is where you use to represent 2 quantitative variables and see their relationship. Then we have measurement issues. So some of the problem when we try to do the study and survey is where you have bias and reliability. Validity is also one of the important things, but it's not really discussed in this course. But it actually comes when you get a result and you want to compare with like existing literature and maybe some of the recent study that's similar to yours, and see like how much is the result difference. But we mostly talk about bias and reliability. So bias is where you have a systematic prejudice in one direction. So say if you do the research and you get like most of the variable like skew on one side, or like accumulate a lot together with some of the most, with the rest is like spreading out. So that's where you kind of like there might be a bias. We also have non-response and response bias. It's coming when you get the result back from your subjects in the samples. So the people who don't respond actually might have their different preference to the people who respond. That's non-response bias. And when you have response bias, it's where you have people with different tastes that respond back to you. That's where you call response bias. Reliability is kind of like when we said a measurement to that give you or anyone else approximately the same result out to time. So say if it's a reliable measurement, yeah, the result should be it can vary, but it should be approximately the same. If you have a study that give you like a wide range of like values. So say one of the things that I'm doing right now is where you like measure the stress using one of the machine when we call Instron. So one of the problem with the Instron is that depending on the materials, the variable can vary from 10 to like 100,000, and you have no idea like which one is correct because you're learning a new materials. So it's where you say, okay, Instron is not a very reliable machines to study the stress of this thing. So that's like one of the example. And reliability also depending on margin of error and sample size as we said at the beginning of this review. So yeah, that's mostly it. Let's see how many do we have left. Oh, that's a lot. We actually learned a lot in this course so far. So yeah, we have sampling issues. So again, these are coming from like the amount of result that you have. So mostly low response rate can create some bias, and non-response bias, as we say, the people who respond might have different preference compared to people who don't respond. Question wording issues is where I think we actually talk about this in lesson 2 or 3. You can review like the slides if you want to. But mostly question wording issues is where maybe when you phrase it like, do you agree or disagree? That's kind of like a standard way to ask the question. But a lot of times people will ask questions like, do you agree with something? And or do you disagree with something? And so people tend to answer more yes or more no in those questions, because one of the things with human is that it's just like a psychology thing, is that we hate the fact that someone tells us that we cannot do something. So question wording issues can create some bias. And then we have sampling techniques. So as I say, maybe the way that you take the sample, or like it's also the way that you ask questions. So it's just more general way to say sampling techniques. There are more things involved in it can create the problems. Sampling frame selections. So this is a major thing when you choose a sample yourself. So if you choose, first of all, when you pick a sample from like a sample frame that is not very similar to the populations, or not very close to the populations, then that is a problem already, because kind of like there can be a bias in there when you select like a sample from a small sampling frame compared to like a big populations. Experiment issues. Again, the ideas that like related to like experimental studies specifically, where we have confounding variables, it's always the issues where there are always things that you cannot control in your research, and that's why we have research and development going on all everywhere and all the time, because we're all trying to fix these things and trying to just study one of the effect. But in reality, just be honest, like sometimes it's really hard to just separate the effects of different factors, because most of them are interrelated to one another. We also have something called placebo and experimental effects, something we don't actually discuss in this class, but it's really good to know. Placebo is where say if you have like the subjects, and these are usually applied for psychology, when you tell the subjects like, okay, I'm gonna give all of you guys this kind of pills, and let's see what's the effect, and we're trying to study. Placebo is where you have the subjects think that they receive the treatment, but they don't actually receive it. They just receive like a pills of like inert ingredients. So usually like helpful in maybe pharmaceutical study and psychology study. Experimental effects is where you have experimenter with an expectation of an outcome and may influence the behavior of the subject. So in other words, it's kind of like the bias coming from the experimenter. We also have observational study issues. So besides the problem of randomization and the lack of control that you have in observational study, they also have always the effects of confounding variables. It's just come down to how well you can design your study. And then you have someone try to do the observational study and claim that there's a causal relation between the two things that you're doing. So that's not right. You can only draw an association from those results. Again, we have lack of control on the subjects, extend the result inappropriately. So things with like observational study in reality is that sometimes it's really hard to find like a big enough sample, or like sort of like a sample that fit with your time of study or your context of the research. So sometimes people just choose that to extend the result from past data. So that can be some of the problem with the issues, because the association might not be true anymore in the time or like the context that you do the study. So yeah, that's mostly with conceptual. Now we come to more like numerical study, like materials, where we have the 5-number summary. So whenever you have any kind of data and you want to summarize them, say what we're talking about here is quantitative, then we have the 5-number summary. And this is very similar. We have minimum, lower quartile, median, upper quartile, maximum. And the way that it's usually represented is in the box plot, where you have this is Q2, Q3, Q1, this is minimum, this is maximum, as we said, and some asterisk below or above for outliers, something like that. Very and then we have measure of center, measure of variability, and measure of relative standing. So these are just like the concept that derive from the 5-number summary. So as long as you understand the 5-number summary, then you should be in pretty good shape to like understand these concepts. Measure of center, you have mean and median. So mean, very similar, as it's just like an average of every values in the samples, and the median is where you put every values in an order and pick the middle value. So sometimes we also talk about sensitive and resistant measures. So the mean is what we call sensitive measures, because it's usually very it can be driven very easily from outliers, like big outliers or small outliers. The mean value can easily change because it accounts for all the value. But the median is more like a resistant measures, where we say the outliers doesn't have that much of the effects on the median. So when to use which, depending on your samples and if you have any outliers or not, then you're going to use mean or median. Mean is better for a good sample without any outliers, like a symmetric one. The median is more suitable if you have outliers. Similarly, for measure of variability, we also have a sensitive and a resistant. Standard deviation is where you call is a sensitive measures, where it accounts for all the values in the samples and like their difference from the mean. And IQR is the resistant one, where you only take Q3 minus Q1, and so it's more suitable for samples that you have outliers. Then we have measure of relative standing. So this is what we learned last week, percentile and standardized score. So percentile, the one that we usually go with is the percentile related to the 5-number summary, where you have 25, 50, 75, those kind of percentage. And standardized score is just defined by how many standard deviation of your value from the mean. So also called z-score. So you can find it by value minus mean divided by standard deviation. But in this course, if you have any calculation in the exam, especially when you're not, you don't have access to the calculator, everything should be pretty easy to do it by hand. So yeah, don't worry about that calculations part that much, especially when it's not even like the big focus of this class. Finally, we have distribution shapes. So these are the way that you're gonna display the data so that they can communicate like the information quicker and better and more effectively. So distribution shapes, we have a lot of plot that we already learned. Box plot, histogram for measurement variables. So a box plot is a very similar one, a very like common one for like 5-number summary. And histogram is where you have a lot of data and you try to divide them into groups of different range and to see like the frequency of the values appear in that groups. You have pie charts or bar graph for categorical variable. So usually the thing we're gonna see the pie charts is like see the distribution of maybe like percentage of each industry in the GDP, or things like how many percentage of people vote for this party in the maybe US election. Then we have bar graph for ordinal variable. So bar graph is more like the one that's pretty, commonly used, and it can apply for a lot of variables, categorical or measurement. Time series plots, as its name implies, it's kind of like show you like the long-term trend over time. And you can actually put like several values. So say you can put like oil prices on one line, on one of the say if you have oil prices and you have maybe want to see like how inflation, you can show them on the same graph so that if we can draw some conclusion from it. We also have other distribution shapes of your populations. So say you have symmetry bell shape. It's called something called normal distribution, and the median is approximately the mean. Or you can have like a skew right, and this is skew left. So skew right is where you have to care about the relationship between the median and the mean. Here you're gonna have the mean is slightly bigger than the median because you have this big value tail. And similar here, you have the mean is smaller than the median because you have this small value tail. We also have something called a bimodal, especially when you try to like display the populations of like a characteristic of the entire populations, regardless of their gender. So usually female is going to have a peak and male is going to have a peak, depending on which peak is higher, depending on how the ratio between men and women in that populations. Finally, we have the empirical rule, something we just learned on Thursday. So it's kind of like allow us to see what is the kind of like rule of thumb to see the distribution of a normal population. So say, what is the range here within one standard deviation from the mean? You have 68% of your sample. If you 2 standard deviations from the mean, you have 95%, and then 3 standard deviation is 99.7%. And the very important thing here is that if you want to use empirical rule, the population have to be at least normal distribution. So say if it's not specified, there's nothing that you can conclude from there. So the answer is going to be nothing can be concluded because more information must be given about the populations. So having said that, that's most of the thing that we already learned so far and just the materials. So I'm going to go through the practice questions right now, which I took from your practice exam. So you can always find them there or do it yourself. I figure it's like 35 questions. So it might take some time, but yeah, we can work on that. So if you want to work on this alone, please mute me when you watch this video because I'm going to give out the answer on my own. So question 1, suppose that there are 2 methods to test the amount of milk fat in 2% milk. The results of 5 trials of each method on the same milk shipment are shown below. Okay, you have method 1, everyone with the same value, and in method 2, there's some kind of variation. When examining the results above, which method is most reliable? Which method produces the least biased result? Now, when we talk about bias and reliable, we said bias is where you have a very strong prejudice on something. And the more biased one is where, and the reliable is where you have some variations. Oh, the reliable is where you have some approximately the same value over time, maybe some little variations. So if you look at this, most reliable is going to be method 1 because it gives you, even though it's very hard to believe that it's the same value all the time, but the change is much less than the one from in method 2. So it's more reliable, it's going to be method 1. So B and D are wrong. And then the least biased result. So bias is where you have all of the value prejudiced on one direction compared to the actual. So the actual value, like it's 2% milk, but method 1 only give you every one of them very much small, like all smaller than 2%. So there's a strong prejudice towards the smaller number. So it's the more biased result. So 1 is not right. In 2, there are some variations, and it actually go above and below 2%. So it's less biased. So it's going to be method 1 and then method 2. So it's going to be C. And this question, I feel like, is a very challenging one, and it's kind of like confusing as well. So I would say if you have any questions with this one during like rewatching this video or during like the practice exam, please feel free to email me and Dr. Ellie so that we can work on this together. Then we have question 2. Again, mute me if you want to work on this alone and before you can watch my answer. Are accidental injuries more common amongst sea-based oil platform workers than amongst workers in land-based oil drilling? To examine these issues, a researcher would A. carry out a randomized double-blind experiment. B. carry out a randomized unblinded experiment. Okay, first of all, you cannot assign people if they want to work on a sea-based oil platform or a land-based oil platform, because that all depending on their company. So it cannot be experiment. Now, we only have C and D. Compare similar types of injuries amongst people of similar age in similar types of jobs between the two situations. I don't know, it's a so-so for this one. D. survey people who have worked in both types of locations and ask them under which circumstances they observe more injuries. Okay, now the problem between C and D is like C, they have similar types of injuries, similar ages, similar types of jobs, and kind of like compare them. So it allows us more kind of like even though it's not an experiment, it's an observational study, it allows us to have more like control on the variable. When you pick people of the similar ages, doing similar type of jobs, and have a similar types of injuries, and just compare maybe like their level of seriousness or like how long it takes to heal and all of that, then it actually sounds more right to me. But in D, when you look at it, the problem is like you survey the people who have worked there and ask them about which circumstances they observe more injuries. Honestly, this one doesn't really tell us anything about the number of actual injuries. It's just people opinion. I mean, it might be close to the fact or it's not. So I don't think D is the correct answer. So it's going to be C. Now, we have question 3. Again, stop me if you want to work on it. What's the biggest problem with having closed questions on a survey or in an experiment? A. The choice of possible answers is critical, and if not done properly, can lead to misleading information. Now that makes sense. Alright. B. The participants respond are hard to categorize or summarize. Like what? You have the experiment response, and you can only have that many answer choices, so you can just give them answer choices. So it depends on your answer choices and not the questions. So B is not right. C. There's no problem with closed questions. They provide the most accurate information by offering such an explicit choices. Well, honestly, the thing with closed questions is that sometimes you limit the choices. So you give them choices, but some of them might not fit with like their actual choices. So some of the people will have like weird choices. So there still exists a problem. I think we talked about this kind of bias before in lesson 2, but yeah, there is a problem with closed question, and it's not that they don't have any question problems. Do you have to worry more about how a closed question is worded than how an open question is worded? Okay, the thing about open question and closed question is that closed question, they give you choices to choose, and open question is that they allow you to like answer whatever you want to. So the thing is that it's not a problem of how they word it. It's how vaguely they want, like how open you want your answer is. So D is not the answer as well, and so A is the answer. So when you look at A again, the choice of possible answer is critical. If it's not done properly, can lead to misleading information. And what happened with this is like sometimes people tend to like, if the researchers already have some expected outcomes in their mind, the multiple choices that they give in closed questions can maybe like biased towards some directions, and it makes the subjects or like the people who do the sample think that, okay, this should be the answer that I should pick, but may not be their actual choices. So that's the problem with closed questions. It's the choice of the answer. It did related to bias. So yeah, that's question 3. Now let's come to question 4. Again, stop me if you want to work on this alone. In a 1996 study conducted at a Philadelphia restaurant, putting a smiley faces on the bill increased the tip for female waiters, but decreased the tip for a male waiter. What are the explanatory and response variables? Okay, I get this question wrong, but now I kind of like understand how it can be a little bit confusing to some of you. So if you look at this, they ask people to put a smiley face and they measure the tip if it's increased or decreased. So a very clear thing coming from here is that response is the tip, like the outcome that you actually measure. So B and D are not correct. Now, the variable, explanatory variable is what actually confused me. Is it a smiley face or is it a gender? Now, if you look at the two, the study here, it looks like every server, like waitress or waiter, all have to put a smiley face, and it just measure if it's increase or decrease depending on their gender. So increase for female and decrease for male. So it looks like everyone have to put on a smiley face. So it's not an explanatory variable, because if it's explanatory variable, someone is going to put on smiley face and some will not. But everyone here have to put on, and they see what changes in the tip. And they say that it's increase for female and it decrease for male. So the explanatory variable here is going to be gender and not the smiley face. Yeah, this can be a little bit confusing or like hard to see for someone, but yeah, that's the answer for this. Now it's question 5. Again, stop me if you want to work on it. And this is like a really long worded questions. But luckily in the practice exam, it applies for like 5 or 6 questions, so you don't have to read the same thing over and over. A recent study examined whether subjects with very early stages of Alzheimer's disease have impaired reaction times in recognizing common street signs. In this study, 10 subjects with Alzheimer's and 10 subjects who have not been diagnosed with Alzheimer's used a driving simulator video in which they view the road from the perspective of a car going 60 miles per hour. Whenever the car in the video passes a street sign, they're supposed to click a button as quickly as possible and stated the shape of the sign the video has just shown. The amount of time it took from the sign appeared to when the subjects declared the correct shape was recorded. In one situation study, the Alzheimer's subjects took a median of about 100 milliseconds longer to declare the shape of a sign. This study is, okay, so you have a group of 10 subjects with Alzheimer's and 10 subjects who have not been diagnosed with Alzheimer's. And the treatment they want to use is that you watch a video and you press the click a button and say the shape of the sign. And so, okay, you have 2 different groups, but you cannot randomly assign who get Alzheimer's and who cannot. So also, obviously, it cannot be an experiment. So C and D are wrong. Now, if you have a control group or not control group, so a subject with Alzheimer's and a subject without Alzheimer's. So obviously, you have a control group and someone with the problem, with like the traits that you're looking for, which is Alzheimer's. So this is an observational study with a control group. Now, question 6. Following the scenario in question 5, an obvious criticism of the study is that, okay, this is the questions that, again, stop me if you want to do your own work. The problem with this question is that I also get it wrong, but I get really confused between 2 choices. And the thing with me is that I always pick the wrong choices. I don't know why, but it's just the case. So an obvious criticism of this study is that A, using the median to describe the difference in reaction times is a bad idea. Okay. The choice to use median or mean is depending on the populations, and it doesn't tell us anything about the data. So it's possible to use the median if the data actually have some outliers. So A can be correct, can be not, so I leave it there. B, using a video of moving car might not provide realistic situation to examine. I'll put B there. It doesn't really tell me anything much. C, using people without Alzheimer's to compare was unnecessary. Okay. You need some people without Alzheimer's. That's like the entire point of learning the problem with Alzheimer's and not some other variables. So C is not right. D, the population size is unknown. Again, you cannot control like how many Alzheimer's people are there in the entire world population. So, and then the thing with like samples is, and as we said, like the reliability is depending on the sample size and not the population size when we talk about margin of error. So the population size is not really a concern here. So it's only A and B. So at first what I pick is that I pick A, but now I think about it, like you can always have outliers. So A can be right and can be wrong. So it cannot be an obvious criticism here. So an obvious criticism, it has to be something definitely wrong. So if you look at B, that's the only choice that we actually have left. And the answer is actually B. Using a video of moving car might not provide realistic situation examined. So what happened with like Alzheimer's, if you look at the previous question, is that you have impaired reaction times in recognizing common street signs. So the thing we have to care about is the street signs, right? So using a video of a moving car, it can the reaction time Alzheimer's had something to do with reaction time. So when you think about like using a scenario of a moving car, it can make sense. But the thing is 60 miles per hour and like you don't need to use a moving car. The reaction time can come from any kind of thing. And the moving cars can actually create more problem because when you go that fast, 60 miles per hour, it can create some blurry and some other effects in Alzheimer's patients. And so instead of using a moving car, you can just like make a very simple program when you have like a traffic sign appearing on it and measure the time that they press the button and react to it, right? So using a video of moving car might not provide a realistic situation to examine. So yeah, so that's B, because it actually creates more problem when you have more things. Just like if you have just the only thing that actually appear on that screen is the traffic sign, then that'll be much better control instead of having like a moving car and you have more problems arriving from other contents in that video. Now, the final one, question 7. Again, mute me if you want to work on it on your own. In 1879, Michelson made 100 measurements of the speed of light using a method proposed by French physicist Foucault. The measurements averaged 299,852 kilometers per second. A histogram of these measurements given below. Okay, now if you look at this, it actually gives us kind of like a bell shape. So I would say that it's kind of like a normal distribution. Today, the speed of light is known to be 299,792.5 kilometers per second. Which characteristic of Michelson measures back in 1879 does this information help us understand? Like understand what is the difference? Understand this difference. So if you look at this, you have reliability, confidence, validity, and bias. So at the time of 1879, there's not actually other measurements about the speed of light available. So you cannot really just look at values in literature and compare it. So validity is not a thing, and it's also not what we discuss in this class. So in the exam, you should expect that we're not going to ask you something that we have never discussed before. And then we have bias. So bias, as we define it, is like a prejudice towards some train of the value. So and then we ignore confidence as well because we don't actually discuss it in this class, and it's really not the answer as well. So what I was wondering between A and D is like the bias and reliability. So I think the answer to this is, I don't actually remember. Is it bias or reliability? Definitely one among the two, but I picked the wrong answer anyway. So I would say his measurements, it's definitely higher than the the actual speed of light. So it can be bias or reliability. So let me stop the recording there for a second before. Okay. So I will think about modules. Okay, the last questions. So yeah, the thing here is the difference here, like I think the question should be better phrases as what characteristic of Michelson measurement spec can tell us, can define this difference. And I would say the answer I pick is reliability, but now we think about it, it's actually bias because, hey, let me share it again. Because obviously you can see like the answer that he has is way higher than the actual speed of light. So his measurement, when we said earlier that he took the average already, so most of the measurements are prejudiced toward the higher value. So there's a bias in his result if we assume that this is the correct value. So yeah, that is the everything I have for today. And so I hope you guys enjoy it. If you have any questions with any questions in the practice exam, since now I did it anyway, so I hope I can explain it to you. I'll upload this on our regular YouTube videos, and the next review is gonna be in, I think, slightly more than 10 days, like 10, no, exactly 10 days. It's Thursday the 21st, 10 p.m. Eastern time again. There's no sessions this coming Thursday because it's still exam week, so no new materials to review. And so good luck with your exam, and I hope you see you guys on Thursday the 21st.